Hi, welcome to Shashcode. My name is Lisa Shashkova, I'm a software developer, and today we will learn what's the difference between generics in Java and generics in Kotlin. First, generics is a type parameter for classes or methods. Originally, they were created for implementation of collections. For example, you have some collection, for example, linked list, which takes string objects, and if you use generics, compiler will allow you to add new string elements to this collection. But if you try to add some other object, there will be a compilation error. So generics allow you to check your code quickly, early, right during compilation phase, so you won't get such errors at runtime, which is really great. In Java, you can, for example, add generics to your class, and then you can initialize instance of this class and specify which exact type you're going to use. In Kotlin, everything is very similar. The syntax is different, but well, again, you can create instance of this class, and even there is no need to repeat your type again, because compiler is very smart and it understands the type T here right from parameter which we passed to the constructor. So they are pretty simple. So what can be wrong with that? The most important thing here are different types which we can try to use with your generic class or interface. Generic types are invariant. That means that list of string isn't a subtype of list of object. At the same time, list is subtype of object type. For example, here we are creating list of strings and reassign it to the list of objects, and then we'll try to add integer element to this list. Of course, it will produce error. That's why compiler in Java doesn't allow to do things like this. So generic types are invariant. That's why compiler doesn't allow to assign list of objects variable to list of strings variable to the list of objects variable. But what can we do here? Sometimes we need such property because, for example, we have some implementation of our own class list, and we have the method at all which just takes list of elements of type E somewhere, and we want, for example, to implement a method copyAll, which copies elements from one list to another, and the list we are going to copy elements to is list of objects, which is pretty safe. Why not? We can copy put list string elements into list which contains objects, and it's pretty safe from our point of view. But compiler doesn't know anything about it, and we'll get compilation error here because, again, list of strings isn't a subtype of list of objects, and compiler doesn't allow us to do it. But we still need to do it. We still need a method. We still want to call this method with our types. And in this case, in Java, we can use a wildcard type. Here's how it looks like. And that means that this generic takes not only objects of E, but also any type which which extends our class E. All the subtypes are also possible here. So after that, we can safely read E objects from this collection, from our list. But because every subtype can be easily casted to type E. Unfortunately, we can't write such type here because, well, we don't know which exact type is used in the current implementation, so we can't write values there. But now we get this property which we wanted to have in our language. Now list of strings is a subtype of a list of this, our wildcard type. Such property called covariance. Of course, with such a definition of our interface, now we can safely use add all with our list of objects and list of strings, because now compiler understands that it's okay because string is subtype of object, so we can safely put string elements into list of objects, which is pretty great, and everything works fine. Of course, there is the opposite case, like when we want to define type which isn't subtype of the current type E, but is super type of the current type E. So it's either E or any of its super types. In this case, on the opposite, we cannot read elements from such class or type because we don't know which exact type we should read, but we safely can write E objects there because it's either E or something bigger, something upper in the classes hierarchy. And again, a list of objects is a subtype of list of our wildcard type. And this property called contravariance. How to remember when should I use extend, when should I use super? There is a pretty simple rule. If our type or class interface, if you can safely read from this type but cannot write, such class called producer, because it can just return elements but can't read elements of this type. If other type, if you can't read elements of this type but can safely write, such class called consumer. Yeah, because it just returns values but doesn't take it. It just consumes. And there is a very simple mnemonic rule, PEX, which means producer extends, consumer super. That's how you can quickly understand which option you should use here, extends or super, in your wildcard type. For me, it's usually much simpler just to imagine an example. For example, the simplest like string object, you remember their inheritance, and you can just try, okay, I can add string element to list of objects, okay, then I should use extends or super or whatever I need here. This is much simpler than remembering some complicated rules. Of course, the similar options, similar wildcard types exist in Kotlin as well, because again, you can define some type. For example, we just returned type T, and again, you can, for example, you can define method which takes this our instance of source, and it's perfectly safe to store source of strings in a source of any variable. But again, compiler doesn't know about anything about this type. It doesn't know it is safe, so it will show you an error, something wrong happening here. We need a way to explain compiler that our type just returns type T, and it's okay to assign it to use any type here in our generic. And we can use the keyword out. Now this operation is safe, that's great, and it's equivalent of Java's wildcard types. It's called declaration side variance because you can see we use this keyword inside our type declaration. In case of Java, it was a use case declaration, because we use this wildcard in a place where we use this type, where we create instance or of our type. But here we use it during our declaration. So all these keywords are called variance annotations. So there is invariance, covariance, contravariance. And if we want to explain it to our compiler, we should use different keywords for different languages. In Kotlin, they are out, which means that our type is producer. And we can use another keyword in, which means that our type is consumer. And again, the creators of Kotlin language created another mnemonic rule. This is how you can easily remember which keyword use when. Okay, so we discussed that declaration side variance exists in Kotlin, which is great. And so you can use variance annotation to your type annotation. But use side variance also exists in Kotlin, exactly like in Java, because sometimes we really need it, just because there are classes which both takes argument t and return argument t. And well, we should do something with that too. We don't want to describe just a strict rule for our type. We want to make our API as wide as possible. And of course, the same words, keywords out and in, can be used here again. So we can use our variance annotations to type usage. And for example, here we can implement our function copy by adding out annotation right in a place where we're using our generic function. And again, that means that, for example, in function copy, we don't write values to our variable from, we just only read it. That means that its producer is just return values. It just returns values. And that's why we can use out keyword here and use our from variable in the current context. It's a just restricted projected array. That's why it's called type projection in Kotlin. So in fact, it's just a use side variance, but it's called a type projection. Sometimes we just don't know anything about type. But we still want to use it in a safe way. And how can we explain that we can use anything here in our generic? As we remember, everything in Kotlin is a supertype of nothing and subtype of any with question mark. Of course, we can use the following strings, like for producers we can write out of any, for consumers we can write in and nothing, but there is a simpler way. We can just use this star, which substitutes such constructions and which is more preferred way for using in Kotlin. Great. Of course, we can use generics in our functions, both in Java and in Kotlin. You can see the meaning is the same, only the syntax is different, which is pretty logical because, well, syntax is different in both of these languages. And that's, again, how we can do it. We define our function with generic, and then we can, when we're calling it, we can pass type we are going to work with. For generics, also, we can define some bounds. It's called generic constraints. For example, we can define the most popular ways to define upper bound. We can write, okay, our t should extend comparable type, and we can write it right inside our generic declaration. And again, compiler check this during compilation stage. And the last but not the least important thing, how generics exist at runtime. Both in Java and Kotlin, they use generics information about types only during compilation. So they erase type information about arguments at runtime. Well, because original generics were created to check types during compilation, so there is no need to store this information at runtime. But there is one thing, because in Kotlin there are inline functions. It's a keyword which you can add to a function, and during compilation, Kotlin won't create a new instance of function. It's just replace your function call with the function body. So this is how it works. And sometimes this function can be a generic function, and in this case you of course want to use your type which you declared in your type definition inside function body, and in this case you can add a keyword reified, and you can tell Kotlin compiler, oh, save please type information for this function, I really need it. And after that, Kotlin compiler will store type information in this case. So I think these were the most important things about generics in Java and Kotlin. So let's try to make some conclusion for things we've learned today. Generics exist both in classes, for classes and methods, both in Java and Kotlin. You can describe wider types in your program by using so-called wildcard types. So you can use type variance. There is a specific syntaxes and keywords for producer types and for consumer types. In Java, there is only use site variance when you define your wildcard type in the place where you use type. In Kotlin, there are declaration site variance when you use out or in keyword right inside type declaration. There is a use site variance which is called type rejection, and there is also a star projection. Also, generic constraints exist both in Java and Kotlin, different syntaxes, and both languages erase types, but in Kotlin there is a reified keyword which you can use for inline functions. That was a very quick overview of generics which we have in Java and in Kotlin, because in both languages they are pretty important part of the language. I want to repeat it one more time. Originally they were created to check types you're using inside your classes, inside your type parameters during compilation, and it's a good style to use them in your code because it will help you to find errors in your program earlier on compilation stage instead of runtime stage. I hope this video was useful for you. You can always find additional information in official Kotlin or Java documentation. Feel free to ask your questions and leave your comments. See you in the next video. Bye!